A first problem here, a dock worker applies a constant horizontal force of 80 newtons to a block of ice on a smooth horizontal floor. The frictional force is negligible. The block starts from rest and moves a distance 11 meters in 5 seconds. What is the mass of the block of ice? So here, a dock worker applies a constant horizontal force. So it is being pushed with a magnitude of 80 newtons. So let's put some labels, and here we'll try to call this as F equal to 80 newtons, so applied force F. So next is that it's a smooth horizontal surface and the frictional force is being neglected, so there's no static and kinetic friction present. The block starts from rest, so we need to say initial velocity along x is equal to 0. And then it moves a distance 11 meters. So here to here, shall we say x sub o here is simply equal to 0. And then your final distance x is simply equal to 11 meters. And then each time is simply equal to 5 seconds. Okay, so again, let's put some labels for your distance x na 11 meters. So you'll have 11 meters with a time equal to 5 seconds. So if you'll notice, it's asking for its mass m. It's looking for its mass m. So sa kinematic equations, also walay mass m dito rather Vx Vox plus axt, then x minus x sub o equation 2 Voxt plus 1/2 axt squared, x minus x sub o, and then you'll have Vox plus Vx times t all over 2, and lastly Vx squared minus Vox squared is equal to 2ax position x minus x sub 0. Okay, so walay m diri so it's impossible nga sa kinematics nimo makita, pero ang m is makita nimo sa dynamics or sa Newton's laws. So a tendency is that all we have to do next is simply to draw a free body diagram for this case. So what are the forces nga naa? Applied force 80 newtons towards positive x-axis. Next is that the normal force, which is upward. So next is your weight, which is simply moving downward. Okay, kana. Okay, so let's put some labels again. Forget to put labels. You'll have your normal force, applied force, and then weight. Okay, tulo lang kabog forces ang naa. So walay friction because frictional force is negligible tungod kay smooth ang surface. Okay, next is that ibalhin nato siya sa usa ka free body diagram. So formal nga coordinate axis. Okay, so ang tendency is that you'll have here normal force nasa positive x-axis, and then you'll have positive y-axis. So your applied force is towards right, so F. Your normal force is towards up, and then your weight is simply downward. Okay, so here, if you notice, is that kung magamit tag F is equal to MA here, if you notice, here, kinaraman dira ang mass, no? We're going to use summation of forces is equal to MA. So, here, ang motion kinaraman dira paingon diri ang side. Okay, so acceleration is going through this side here. So, take note that bawal ni may butang sa free body diagram ang acceleration because ang pwede ra mabot lang sa free body diagram are forces. Acceleration is not a force, so bantog na ra siya sa kilid. Again, it's summation along of forces along x. It's because ang acceleration is horizontal lang. So if you'll have to add all forces along y, that is simply equal to 0. Balik ko na ko. Kaya acceleration kinara sa horizontal, unaffected imuhang forces nga nasa y. So here, we need to find the acceleration here in order to solve for your mass m. So here, what we're gonna do is simply, pagpangita sa acceleration, we're going to use kinematic equations. Okay, so here, solve for A. So, ang equation nga itong gamiton kay equation 1, no, it can't be. Walay final velocity at this point here. So, we're going to use equation 2. So, you'll have x minus x sub 0, and then you'll have voxt plus 1 half ax t squared. So, basically, x above is equal to 0. Initial velocity is also equal to 0. So, a tendency is that you'll have your acceleration multiplied to both sides. So, you'll have 2x is equal to ax t squared. Divide t squared both sides. So, acceleration is equal to 2x over t squared. So, you'll have here 2 times 11 meters divided by 5 seconds squared. So your acceleration is basically equal to 0.88 meters per second squared. Okay, so we already have the value for your acceleration. So we could able to substitute this one here. But then balik ta diri summation of forces along x is equal to ma. Balik ko na ko ang explanation nga nung ma ang x0 ang y. Ang imong acceleration is purely horizontal, so bantog ma. So ang vertical wala. That would be equal to 0. I-add ni mga tanang forces along x. So, isa naman ka force. So, that would be your applied force. So, F is equal to ma. So, a tendency divide m both sides. So, your acceleration is equal to, I'm sorry. Divide both sides by a. So, you'll have your mass m is equal to F over a. So, you'll have 80 newtons divided by 0.88 meters per second squared. So your mass is simply equal to, in kilograms, that would be equal to 90.9 kilos. That would be the mass of the ice. Next, for letter B, if the worker stops pushing at the end of 5 seconds, how far does the block move in the next 5 seconds? Okay, so the problem goes like this. Muna block of ice having a mass of 90.9 kilograms and it is being pushed 80 newtons for 5 seconds. First 5 seconds kana 5 seconds ni 11 meters ang distance. Okay, after that kay iha dayong gibuyan ang block. Okay, wala niya gipush. So meaning to say na slide ang block at this point here. Okay, nidagan na gihapon siya. So here, for the next 5 seconds, it's asking for pilay distance. Okay, iyahang ma-travel. So ang tendency is that take note that for this case, you need to solve for the final velocity ngayong abot diri. So nakay situation 1, which is imong data kay katong nasa letter A, and then the situation 2. So we need to find the final velocity at this point here, pilay final velocity niya. In which magamit nato nga mahimong initial velocity aning isa. Okay? So, ang tendency is that we're going to solve for the final velocity. So, you'll have here, we're going to use equation 1. So, you'll have Vx, Vox plus Ax t. So, you'll have 0. This is 0. So, 0.88 times 0.88 meters per second squared times time nga 5 seconds. So the answer would be 4.4 meters per second meters. Okay, so meaning to say, here at the end of this point, here's situation 1, your final velocity is equal to 4.4 meters per second. So take note that it's looking for your x sub o for your situation 2. So a tendency is that we're gonna write the given again. So you'll have here your x sub o for this case here for your situation 2 still is equal to 0. It's looking for its final position x at this point here. Time is also given by 5 seconds. Initial velocity is simply equal to 4.4 meters per second. Okay, so here. So a tendency is that what equation will we use? 1, 2, 3, 4. Equation 1 to look for your distance, nope, x. Equation 2, okay, I guess yes, that would be your equation 2. Okay, hala, walay acceleration. Okay, so ang tendency is that acceleration for this case is simply equal to 0. You know why it's equal to 0? The moment gibuyan niya ang 80 newtons, constant na siya nidagan. Okay, frictionless ang floor. So we're going to use equation 2 for that case to look for your x sub o. So you'll have v sub ox times time t plus 1/2 ax t squared. X sub o is simply equal to 0. And your acceleration is also equal to 0. So you'll have your x is simply equal to 4.4 meters per second times its time nga 5 seconds. So the answer is simply equal to 22 meters. Second example, draw a free body diagram of a block which slides down a frictionless plane having an inclination of angle 15 degrees. The block starts from rest at the top and the length of the incline is 2 meters. Find the acceleration of the block and its speed when it reaches the bottom of the incline. Okay, so first things first is that we're going to draw a free body diagram for this case. Okay, so here, since na surface of contact, so meaning to say na ay normal force. So, i-incline mo ni siya. So, perpendicular sa incline is your normal force. Next is that your weight. Okay, so ang tendency is that para di mo ma-confuse, we're gonna denote this as your positive y-axis. Okay, and then ang normal force kay tara, the green one. This will be your normal force. And if you extend this one, kini, this will be your negative y-axis, right? So, ang weight nimo is vertically downward man na siya. So, ang tendency, dili ang weight ingani ha, along negative y, di na siya always true. Kung incline gani, so vertically downward yun na imong weight. Okay, so this is your weight. So, kung ang kani nga angle, gikan sa negative y, paingon sa weight, kung pilang angle of inclination mo, pud na imuhang angle diri sa negative y paingon sa weight nimo. So 15 degrees. This is also 15 degrees man. Okay, napabailain. Frictionless ang plane, so walay friction. Okay, maora. So ang tendency, it's asking for its acceleration for this case. So naidua ka pa makitag acceleration mo gamit kag kinematics. or magamit kag F is equal to MA or Newton's second law. So for this case, we need to note that nasa length, okay, length sa incline, kining incline, which is simply equal to 2 meters. Okay, ang length aning incline is simply equal to 2 meters. Okay, kana. So we're gonna put some labels for that one. So kana kay 2 meters ni siya ah. Kini. Okay. Oops. Okay. Kana, that would be 2 meters. Okay, so ang tendency is that we'll have to list for all the given. X sub O is simply equal to 0, right? So, bahalag take note, bahala pag naka-incline na siya, you will treat it as a horizontal na motion. So, the block starts from rest, so initial velocity is also equal to 0. Imong horizontal distance is simply equal to 2 meters. Okay, so it's looking for letter A for the acceleration. So, possible ba nga magamit ta og um, kinematics nga walay time and walay final velocity? Okay, is it possible? Okay, equation 1. Is it possible kung magamit ta og kinematics nga walay acceleration and walay time? So it's not possible. So one tendency is that we're going to use this free body diagram, meaning to say, gamitin nato ang Newton's second law in order to solve for the acceleration. So here is that atong itilt ang atuang free body diagram. Okay, so i-formalize nato ang drawing. Okay, so we have normal force nasa positive y-axis. So, mean to say, mo niyang normal force. And then, nasa left side sa y-axis is your weight. Okay, having an angle of 15 degrees gikan sa negative y. So, more na siya nga mga forces duha lang. So, note that you need to use component method para sa wx, wy. Kani kay vertical man ni siya, panaog. So, this would be your wy. And towards left ang wx. So, pwede rin mo i-disregard. So, to solve for your wx and wy, so imong wx is on the what? Adjacent side sa imong, or the opposite side sa imong angle 15. So, you'll have w sine 15. Unya na iyahang sign nga negative or positive. Later on na, inig-add na nimo sa mga vectors. So, you'll have mg sine 15. And that would be equal to, given ba ang mass sa problem? So, I guess there's no mass for that one. Okay, sige lang. And then your wy is simply equal to w cos 15. Anong cosine gani? Adjacent ka. Okay, so you'll have mg cosine 15. Okay, so next is that accelerate man siya towards this direction. So, ang tendency is that, shall we say, ang kaninga direction kay negative, and then right nga direction is positive. So, meaning to say, acceleration is towards left. So, here you'll have summation of forces along x is equal to minus MA. Okay? So MAX. Again, nga nung negative, it's because we have assumed nga ang direction diri pa right kay positive and the direction pa left is negative. So we're going to add all the forces along x. So ang tendency, isa lang ka forces along x or ang horizontal force, that would be your WX, which is towards left. So that means to say negative. So you'll have minus WX, isa naman kabuok. So equate lang dayog minus MAX. Okay, substitute the value of your WX here, mg sine 15. So you'll have negative mg sine 15, okay, is equal to negative MAX. Okay, so now yung mag-cancel out imong mass m, mag-cancel out, and including the negative one, cancel output. So your acceleration basically is equal to g sine 15. Okay, so acceleration AX is equal to 9.8 newtons. So it is understood nga unit nga kg. Not newton. 9.8 meters per second squared sine 15. So ang acceleration is simply equal to 2.54 meters per second squared. Okay, so this will be the answer. Next, for letter B, it's asking for the speed when it reaches the bottom of the incline. Here, what would be the final speed? It's asking for letter B. So, here, magamit na kita kinematics to look for your final velocity. Okay, so if you'll notice, natay data sa babaw, position, initial velocity, and then the acceleration. So, walay time. So, basically, equation ng walay time, that would be your equation 4. So you'll have Vx squared minus Vox squared is equal to 2ax quantity x minus x sub 0. So na yung ma-0 aning a term, that would be your x sub 0 and your initial velocity Vox. Okay, so you're looking for your final velocity, so you'll have here square root both sides of the equation para makuha ang square. So, ang tendency, you'll have your Vx is equal to the square root of 2 times its acceleration times its position x. So, you'll have here 2 square root of 2 times 2.54 meters per second squared times its position nga 2 meters. Okay, so your answer will be 3.18 meters per second. So that would be your Vx. So there are two types of answer here, plus minus sa radical sign. But since it's towards left man, so most likely you prefer the negative one.